DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. Whether you need to manage bots, protect cloud applications at runtime, stop form jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
Captain's Log, supplementary. The away team has returned safely from the interview segment, where we learned about the LFX.dev project. That's right. Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake, Buena Vista. We are excited to announce our first round of speakers, which requires me to take a deep breath. One moment. Leslie Carhart, Dave Kennedy, Alyssa Miller, O'Shea Bowens, Marina Savata, Patrick Coble, Chris Eng, Eric Escobar, Nick Leghorn, Michael Schlatt, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked to register and check out more of our exciting lineup. You can also join us on August 26th at 11 a.m. Eastern to learn how to implement cloud security that actually works. Visit securityweekly.com/webcasts to register now. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. And this brings us, John, to quite a busy week of news. I think there's a couple articles that definitely showed up on both of our radars. Lots of vulns, but then some non-vuln technology to talk about. But on the vuln side is usually where we start. And here's a little bit of a callback to a topic we covered a couple episodes ago. BlackBerry admits they have a vuln. And I know you saw this. Anything that in particular you wanted to highlight from this particular topic?
Also, we'll see how your segue skills are today. We've got news stories here about the proper way to handle disclosures and vulnerability management as the vendor, and we've got bad stories. I didn't plan that. I just think of it now as we're here, but I don't put this into the good category.
No.
My version of the notes, I know you had a little more to say than I did. I was sort of, I'm trying to keep my snark to a minimum here. I haven't seen a response from BlackBerry yet. I've seen them say sort of like some of the, their reasoning for why they were pushing back on whatever around this. They couldn't update all their downstreams, and because that never happens. Let's see, I can't keep the snark out of this one. I'd love to hear better reasoning from them. And I think I know what the reasoning is, but they're not going to admit it, that they just didn't want to tackle this, or I don't know. That doesn't sound right. So I don't know. It's a little disappointing. QNX doesn't QNX remember right? Yeah, the QNX had a pretty great reputation. I'm sure it still does, but this is you can't just turn a blind eye to this type of thing. So that's where my head is on it.
Yeah, and I think I have to just sort of, keeping on theme, I'll do my Picard facepalm here, in the spirit of BadAlloc was a topic we covered episode 149, but it was really cool because Microsoft went and in a scalable manner found a whole bunch of vulnerabilities, memory safety vulnerabilities, unsurprisingly, in this C-based code, in these RTOSs, these SDKs. So a lot of this shouldn't really have come as a surprise to BlackBerry. Now, we can admit that there is some complexity to fixing vulns and getting them spread out through an ecosystem, but I think here here to try to, in the spirit of trying to find something new and different to say about the topic, I do wonder when we will actually get off of C and C++ due to memory safety issues in these types of areas. And I'll admit that there is a strong performance need on the RTOS, especially side of things. But even when we were talking with Shuber in the last segment, overwhelmingly the Linux kernel is all built in C. But there are some very small steps of device drivers, for example, starting to explore Rust. And so hopefully there will be a future that comes not within when the TNG, for example, actually takes place about 200 years or so from now, or 300 years or so from now, but within maybe an order of a decade where we see better choices of code, let me say that, and better designs that get rid of these types of vulnerability classes. Yeah,
we've got another article along these lines too, right? Its problem is not just memory safety, but which parts of either that language or the API have been made memory safe and which parts haven't. And I think that could be, once you're adding confusion into this whole thing, it's not helping us out.
Oh, let's dive into that confusion. So I think Glibc or Glibc, for those of you who prefer different pronunciations, did have a vuln that they fixed, and then the fixed created another vuln. So this is not necessarily something that's unique to open source, to be fair. We've seen many fixes introduce new and different vulnerabilities because software is complex. And I think this might have been where you were setting me up for that segue there, John.
Yeah. Sorry, I thought I was muted when I was coughing in your ear. Yeah, so let's see here. So first, what's this Glibc thing? You sound like a Berkeley CS grad that pronounces Vi. Maybe they've changed that by now, but for a while I could tell the Berkeley grads. So I had one quote I wanted to read out on this from the article, which is linked in. While the free call is immune to null pointers being passed to it, pthread attribute destroy is not. And that was sort of at the heart of this. So what happened to backtalk, as you were saying there was a vuln out earlier this year. See if I get the CVE quick enough. 2021 38604 for those keeping track of 5-digit CVEs. Or no, sorry, the first one was 33574 because I'm not keeping track of 5-digit CVEs. But anyways, that started off earlier this year. Someone from Red Hat fixed that. Unfortunately, the fix had this pthread deallocator destroy in there, and he wasn't doing the null check himself. And that's these things. I was showing someone who's less of a coder some of my latest and greatest code recently, which is Go. And if you look at Go in particular, a vast majority of the code is actually error checking. So, right, you make a function call, then you come back, check the errors, make a function call, check the errors. This is if you're not being someone junior who's throwing away the errors, but that's a separate conversation. And that's sort of the bringing it back to, I haven't looked at Linux kernel for a while, but we need more and more of these, not just error checking, but null checking. And, you got to be so careful. There's so much checks around just doing what you actually want to do. And I think that's why we talk about wanting to use a language like Rust, which does some of those checks for us, as Go does too. But then also in the event where we don't do that check, there's less likely a chance of shooting ourselves in the foot. So we know Linux is moving in towards doing Rust in some areas. A lot of the OSs are now. We're heading that way. It's probably going to take us a few years to get there, but that's the state of things. And these are big name guys at both of these companies. These are experienced developers that know what they're doing. It's not someone junior, and it still just takes a slip of the mind. And probably got code reviewed as well. And sometimes we'll catch that type of, hey, you didn't check for null, but then again, sometimes you're like, hey, this one does check, or this one's null safe, this one's not, and you have to have very intricate knowledge of these things, keep track of that type of stuff.
Indeed, you do. This is where I also have, in my spirit of optimism for the future, LLVM in particular, and compilers having the insights and the capabilities to run address sanitizers or undefined behavior sanitizers, things that ostensibly could catch these types of scenarios, or at least give some error feedback that says, there might be a null that can come through here, or there's a missing null check, or it can do some initial inference, or in the future some fuzzing to say here is a bad boundary. You've switched from a boundary of the code where you're handling nulls to an area of your thread isn't handling that. So that's what I would just kind of throw onto there. I'm going to keep on to the unfortunate side of vulnerabilities that were coming out this week before we get to the positive side. This one was a command injection. So once again, we're in the realm of C code. But in this case, it's not a memory safety issue. In this case, the researchers discovered they could basically smuggle in some backticks into the name field of a SAML configuration page. And the implication there is that the function call was basically copying a file, and they were concatenating some strings together to build that copy command line and then passing that through into the underlying shell. And backticks, of course, have a nice semantic meaning of executing commands within that shell environment. So for me, this was just one of those, again, my Picard facepalm comes out because it's snprintf, which is a quote-unquote the secure version of the function, still being misused in an insecure way. But also, why is it calling out to shell to do this file copy rather than just using a C API for doing a file copy? So there's a couple things here that I would turn this into if I were doing kind of that just basic code review.
I know why people use system calls to copy files and not use the language itself, but it's unfortunate, right? That's a very good example in particular to talk about that for a second. While you have code review and you have someone go, no, I'm not letting you merge this code because that's crap, and we're actually going to do it the way we do it in a modern language. The first part, the thought before that, actually is probably the more interesting one. And coming back to the conversation we just had with Subra, and he was talking about there's always those cases where I think he was talking about password hashes or Git hashes, right? You have something temporarily in your local branch, you don't mean to merge it in, it automatically gets committed, and basically that's because it's a lower. This will sound bad, but it's a lower class of priority. Some of these parts of an application. So my personal preference, if I'm building an admin interface, it would be a separate branch of code internally so that it's not exposed on the actual customer-facing or public API server. And I do it basically so if someone, I'm looking at it from the reverse point when I have this architecture. If someone compromises the public-facing server, that server just doesn't have admin-type access or codes to do things in the back end. I'm not thinking about it that my admin server is so weak in choosing words. And thanks, by the way, for the guy Schmooze for posting the snarky emoji or meme in a Discord. But it's not quite as great code, right? That's not why I'm thinking of doing it. But at the same time, and I know this is a public admin interface, but still, same thing comes together. If I have that admin interface internally for, resetting someone's password or, making sure someone's getting the right subscription or need to check a license or whatever you do, sort of, administrative type things which a company would do for a customer, I'm not having my top tiered coder write it, right? That's the new guy. Hey, create the web interface. I don't care what it looks like because customers aren't seeing it. It needs to be able to work. So it's just a lower tier of code. And I recognize this is part of the public application for this thing. But our buddies over at Fortinet, their specialty isn't creating web interfaces and SAML processing, right? They're a WAF company and things like that. So this is, let's be honest, second tier to them. That's not where their best guys are working, and that's probably why we see someone running a command to call it to a Unix copy. So you can sort of see the pieces fit together, what's going on there, but that doesn't make it right. That's just something for us as either security people or AppSec people or even management to think about, okay, now that we know that type of use case exists, how do we make sure we minimize that in the future?
No, I think you're right. And perhaps, too, there's a tie we can make back to the conversation with Shubhra about the mentorship aspect as well. Whether there is both the language choice, if our expertise is writing high-performance C code for other aspects, do we really need to be adopting C just because we're familiar with it for these administrator aspects? Maybe the programming language choice would be better, or there is a better way of building a copy command in different languages, so it's parameterized, things like that, better design patterns. So these new people, the new person who's writing the code, it's not their fault. They're basically, rather than being set up to fail, so they have this type of command injection, they're being set up to succeed. So regardless of that, honestly, there are engineering priorities that come into play, but that security still gets attention. And I think a lot of the what's the word? The implication or the underlying theme, I think, really what you were getting to is the software architecture. And again, the architecture, I think, of what you were describing is how to harden this here, and really not trying to pick on a programming language at all, but just saying your choice of programming language is going to influence the vulnerability classes and how well, or the trade-offs or the prioritizations even potentially that you're going to be able to make in that secure design. So I'm going to use that to go one more sort of maybe straddling the fence between good versus bad type of vulnerability disclosure, vulnerability handling before we get into something really good. This one I'm referring to is a Windows elevation of privilege bug. Came out of Project Zero. They reported it. Microsoft kind of said, we're probably not going to bother with it. Project Zero wrote up about it, disclosed it, and Microsoft said, okay, fine, maybe we'll do a little bit more with App Container. And this wasn't necessarily a bad thing. It's kind of nice to see this discussion sort of happen in an open and transparent manner. And I think that the takeaway for me was not so much about, is this really a vuln, or should this vuln be fixed, or how do we prioritize the vuln? But a great example of diving into a particular technology, in this particular case, App Container, which was designed to basically, by Microsoft, who acknowledges, you know what, we have kind of a legacy of lots of software here that has a huge attack surface, which, that's my teaser, we have another article talking about attack surface. But all of this legacy software, we have an attack surface. We need an app container to help contain it, to reuse the word. And what was really neat is that there's some vulns in there. Sandboxes may always have problems. Software may have problems, but it really neat right up from James Forshaw from Google Project Zero was saying, well, let's understand what App Container does. And here is a blog post. It's a really deep dive into it. And what's nice about that is turning that conversation into saying, what's our real threat model, or what are the threat scenarios? Let's understand what App Container is doing, and then reason through, should this vulnerability fix or not? And so from that perspective, I thought that was a really great reason for reading and diving into this type of technology.
Yeah, I haven't got a chance to dive into this one deeply yet myself, but I want to. And the reason being, okay, so a lot of these type of issues we have with Windows, or Microsoft, well, no, let's stick with Windows, this is a really complex beast, man. I get it. And they've come up with things like App Container to try and, help contain. But where it's interesting to me is when you deep dive into some of these type of things and you actually understand what's going on behind the scenes, it gives you ideas yourself on how to, not just how David architects things, but how some of the best architects in the world have sort of come up with these systems for Microsoft and for Windows, and how can that sort of play through into what you're doing at home, or not at home, but you know what I mean. The won't fix thing, whatever. We're talking about switching over here at some point to the positive side of these stories. I want to just try and have one of these days a fully positive episode with kittens and flowers of Application Security Weekly, and not talk about the negatives. How about that?
No, totally. And I think there's, as long as what I'm trying to get to is that we can be we shouldn't be negative. We should be constructive is what I'm getting to.
I'm rubbing off on you.
Yes, exactly. It could be entertaining to beat up on code and et cetera, et cetera. But at the end of the day, what's been gained by that? You've provided perhaps some entertainment about putting someone else down and making fun of someone else's work. But they've actually done some work, and you haven't done anything. Yeah, I'm speaking general here. So that I'm going to use is turning from talking about spaghetti code, perhaps, to a spaghetti detective. Here's something positive, John. Tell us about this one.
Yeah, and I think some people are taking this in a negative way, but I didn't. Spaghetti Detective is a third-party program which basically runs on my local machine. It watches my 3D printer when I'm printing, and through the magic of Rainbow Hands machine learning, they're able to tell if my print has crashed. Which is, if you're doing a print which is hours and hours long, and you're not going to sit there and stare at the thing dry for the whole time, right? So if that crashes 4 or 5 hours after you've walked away, there's chances of fire. There's all sorts of reasons why you want to have, if you can have something, keep an eye on that, and that's what machine learning is pretty good at. So I've used this for a while. Unfortunately, they were doing a little bit of update sometime in the last few weekends, and they they made a change in the platform, which it's. We all make mistakes, all of us, including Microsoft. Had to get that in there, sorry. But what's going on here is they accidentally set things up so that new users might accidentally print on someone else's printer instead of their own, because you can send print jobs also from the system. It's not just watching. But the reason we have this in here and the reason we're talking about it is, if you look at their email saying, or their response that came out and said this stuff, their very first words out of it is, "I screwed up." Very basic. It's very hard to admit we've made mistakes as humans, any of us. But to actually have that front and center to me is so refreshing, and so thank you for just being honest. And these are the things we're doing to actually fix it. We're going to try and make sure it doesn't happen again. That's how you handle these type of things, especially as a small company, right? I understand as we get bigger, we either should have more checks or we have legal or marketing involved. But it was nice to me to actually see this, and I want to highlight and say, hey, thank you for doing that, what I consider the right thing, and as an example to our listeners and on how they can sort of do something like this themselves.
Yeah, I agree, and I think that just fits in sort of that editorial spirit. At least I have when going through articles too, of saying let's highlight the behaviors, let's highlight the things we'd love to see more of. And this is a great example of just acknowledging without qualifiers of mistake, we screwed up. Here's how we'll address it and make things better in the future. Speaking of segues and not having a good one prepped for that, I am going to shift over to attack surface now. This is also a callback to an older episode, episode 142, where we talked about ProxyLogon. And at the time, the technical details weren't available, but now post Black Hat and DEF CON, the researcher has revealed all the very cool technical details about this ProxyLogon vuln. And now I know that we do tend to highlight a lot of write-ups that are unfortunately in C code. This one is luckily has some C# in it, and so we're trying to. And I think last week we did have a JavaScript one, or I think maybe it's this week. But we do try to get some variety in just what the languages are being used within the write-ups. So I do encourage the technical write-up here, or reading the technical write-up. It's interesting to see, but the take-home messages I think is not so much everyone out there who's not even bothering to run an MS Exchange, and therefore this doesn't feel relevant. What the relevant aspect, I think, is revisiting your threat models, revisiting the applications that you've reviewed in the past year, maybe the past 2 years, and you think, we looked at it once way back when in the original series. Why do we need to look at it now when we're on the next generation of our threat models? This is an example of discovering essentially a new attack surface, a new area of, here's some parts of code that people haven't been paying attention to that have led to pre-auth RCEs, these types of things. And, the researcher explained pretty much how they got, I think, 8 or almost a dozen different vulnerabilities out of this, and quite a bit of coin as well. They earned some good money. So that's the one takeaway, I think, is to go revisit with new eyes, new information on threat models you have. And the other one, just very quickly, why would you run your own mail server? In this day and age, there's plenty of SaaS, plenty of options. It's just not something you need to do.
Preach. Yeah, this was a fun one to read. Not just from the threat modeling. It's known I like pretty pictures, but I think it's really interesting looking through the how this is sort of modified over the years. They've got a graph in here. One of the charts was compares, when this started in 2000, 2003 and sort of goes through 2010, 2013, 2019, how these concepts, they've changed and improved. But sometimes when you do that, you're introducing things, right? It's the old, if it ain't broke, don't fix it. But at the same time, we want to keep, I can't even imagine what a product management team is like on Exchange, right? Everyone wants some sort of feature and functionality, especially on authentication, all these different things. If you got your own ADs and you want to be able to sync into O365 or what have you, how do you support all these different combinations and concepts and things? So it's I get why these things get more complex. But this is interesting, a good write-up, a good mixture of technical and a little bit less. But I think, what I'd be sort of curious to see, this is the second one we've covered, I think, this month now, where the researchers are listing out as they go through, made this on their bug bounties. I'm curious if that, I hope, but I'm curious if that encourages others to get into the space.
That's a great conjecture. I'd be curious as well, because one of the things I'd also highlight with this is, in time back to the app container story, is that you get a lot of external researchers or people outside of, in this case, Microsoft, becoming experts on Microsoft technologies, whether it's James Forshaw diving into app container, explaining the fundamentals of it, where you've got this researcher diving into the details and history of ProxyLogon, and making it quite profitable. And what's interesting too, I think you'll find there's probably many more attackers and security researchers who have very detailed understanding of things like font rendering within the Windows kernel, because it is an area rife with vulnerabilities, especially because it happens in the kernel. Great way to get elevation of privilege. And these are people who are outside of Microsoft becoming experts on Microsoft technology. And I think you could probably find similar cases on iOS, Android, and other very consequential tech stacks where there could be some ways to, it could be profitable, make some money through bug bounties, etc.
And just one more on that. Sorry, one more on that really quickly. That's a thread post article, right? No, sorry, this was the DevCore blog post. They link out to the Microsoft blog posts where they sort of talk about this from their point of view, and that's also a very good in-depth read. So we're giving folks a lot of reading to do this week, but there's some good stuff in here.
There's good stuff. There's also some good stuff, again, in some non-C code. This sometimes some straight-up JavaScript is a nice write-up, and a bit entertaining too, about how to hack Apple ID. And it's more about how to set up essentially a phishing scenario that's pretty clever, that got a bounty, again, gotten an award from Apple, so quite legit. But it's very much a deep dive into Apple's particular implementation of OAuth, how it's used how its capabilities, I should say, are used between different services, and whether they challenge for two-factor or they don't challenge for two-factor. And this was just also really neat about cleverly using the post-message interface within HTML, within the DOM. And the other thing that was really neat to me, it was showing that using a very simple, I'll call it old school, bypass of a URL-based security check by using the authority aspect of the URL. And in other words, your attacker domain @ and then the target domain. So a lot of very simple things on the surface that are put together in very subtle and cool ways that identified a security flaw. So once again, another neat write-up, something really cool to learn from. And I would also just point out, there's hope out there for diving into the details of implementations and seeing where there might be some creaky areas that fall apart that you can find vulns in.
Yeah, and also, I'm just looking to see if I can get it here real quick. If I remember right, there was a little bit on this of, oh man, it's one of the fields. Let's see if I can talk and type. Part of one of his initial handholds on here was, I thought it was referred by, he was leveraging. There was one of the fields he was leveraging, Apple was using in a slightly non-standard way. And what that allowed him to do, I mean, response, redirect URL is what it was.
Yes.
And, it's when you're working with a how would I say sort of relatively standardized pattern and a framework like HTML and redirects and things, sometimes as a developer or architect, you want to figure out how do I do what's an elegant solution for this, right? Not just get something done and get it in there, but how can I sort of use what's existing and without creating something new and that type of thing. But sometimes when you do that, you're exposing yourself to things like this, right? So it's my understanding or how I translated this was they're using redirect. I'm not gonna be able to find it quick enough, sorry. But the way they were using the redirect URL seemed like they were using it to check if that's a site that should be authenticated from, if I remember right. Specifies where it's going to, but in their particular case, they're actually looking where it's coming from since it's redirecting back to. So it's one of those use cases where they had a good idea, but they hadn't fully thought through how people could play with it. And probably the threat model would have caught it, but this is a long write-up, but it's more reading for our listeners, but it's another good one.
More reading for our listeners. But we do have, we're going to switch now to try to also highlight in the spirit of our, editorial vision, not just all vulns all the time. There's some cool things being built out there. In a shorter read, you had an article about Google releases their CA service. Tell us a bit more about that.
Yeah, this was, and I meant to go back and check. I honestly don't know if the other guys have a CA service. If they do, I'm not aware of it. But every few years when I'm doing another project, whether it's a day job or not, I'll go looking at some point saying, hey, I'd really, we're starting to do enough key exchange and certificate-based work that'd be really nice to have a CA that actually, makes some of this signing and expiration and all the sort of things you see a little bit easier to manage. I've gone through most of the open source packages out there. Most of them are Java-based. Most of them are sort of painful to use. I think most recently I was using Cloudflare CFSSL to sort of do a CLI-based CA, but I'd rather have a service I can pointy-clicky and have an API call and go and do this type of stuff. And so it looks like finally Google has one. I haven't used it. It sounds good, but that's one of those things where if I can have, that's a core piece of infrastructure, which again is very particular in how it's set up. If I can go and have a third party create and manage that for me with best practices and update it and do all those great things that a cloud service should do, it sounds really appealing. So that's as deep as I've looked into it so far right now, unfortunately. But I think if folks are at a point where they're doing a lot of certificate-based stuff and realizing, hey, we shouldn't be self-signing all our certs, and we can't use Let's Encrypt or something like that for whatever reason, we don't want to use a wildcard, this might be something really good to look at.
Yeah, I think for me, some of the things that come to mind are like, what use cases does this address that Let's Encrypt, for example, can't? As well as it is still nice to see a move more towards certificate-based identities for sort of machine identities, et cetera, even with SSH-based certificate authorities for a developer identity as well. So for me, good step forward. Go ahead.
Yeah, sorry. For me personally, I don't like using Let's Encrypt internally. The answer isn't fully science-based. I'm unfortunate to say it's partially just heebie-weebie-jeebies, but I don't want, if I've got an internal private service, I don't necessarily want to be sending requests or talking about that out public to a third party. So that's just my thought on it. Yeah.
Yeah, no, I think, and that's understandable, and that's why it definitely comes down to the use case and what are the trade-offs you're making. Have that discussion with the security team. They'll have the friendly discussion with you. I think the one thing I just want to throw out there is hopefully we don't see a proliferation of CA services and everybody rewriting their own ASN.1 parsers because, wow, good luck trying to write one that is secure. That's where everything's going to go bad. But speaking of writing secure code, one final article. There's another Go security scanner that's coming out to compete with GoSec. And this one I haven't admittedly looked at it in detail. Another open source from called GoKart. And it's kind of saying some friendly competition, it seems, with GoSec. A slightly different way to do taint tracking, input validation, to tamp down the amount of false positives that might come out of static analysis, this type of tooling, as well as reduce some false negatives by being able to better find and identify exploitable vulns. So this, I think, will be more a call to, I know you, John, have been writing a lot of Go, and I think a lot of our listeners too. I'm curious if for those of you who are writing Go, if you have some opinions on differences between GoSec, GoKart, and some ways you'd recommend using them.
Yeah, I'd love to get people, if anyone chooses, hop on our Discord. I know people have been talking, by the way, on YouTube Live recently when we're live on the chat there. We're usually not looking at that. So guys, we love the conversations wherever they happen, but if you want to talk to us, it's probably Discord. Yeah, I glanced at this. Thank you very much, the guys at, how do you pronounce that? Praetorian? Thank you. For putting in a segment or a section, why did we make GoKart? That makes my life a lot easier. Yes. We go to a lot of open source packages. Google has a new, they have a new vulnerability scanner out. It might not be too new, but I had to click like 3 or 4 links deep to actually figure out why they thought that we'd need another network scanner. So this is handy. Maybe we'll talk about that one in future weeks. But yeah, I use GoSec through GoCI. Well, it used to be Go MetaLinter. It's now GoCI Linter, I think it is. GoSec is decent. As I say in here, it only has 30 rules. These guys, I think, want to do more of the standard, traditional static analysis point of view of source and sync tracking and actually seeing where that goes through. I'm excited to give this guy a try. I haven't yet. I'm a little concerned when I see a project on GitHub, and I know it was developed behind the scenes, but it's got, 4 commits that I saw and 1,400 stars. So that makes me a little not the best feeling. It's just how do you open source something like this and actually let it grow organically? I know as a startup you want to get a bunch of stars and make it look really great really quick, but that I've seen that process elsewhere in the past, so that makes me suspicious. But I think it's probably solid code, and I'm looking forward to playing with it. And I'd love to hear any feedback from people.
Yeah, let us know. And John, I think it's time for us to head to the stars, so take a seat at the helm. And speaking of which, thanks everyone for joining us, and consider leaving us a 5-star rating and like and subscribe the show. Thanks again. We'll see you next week on Application Security Weekly.